A visitor from outside our solar system flew past the sun, and it might be older than the sun itself. Not older by a little, possibly billions of years older. Scientists have now pointed the James Webb Space Telescope at it twice, and what came back has changed how researchers think about objects from other star systems. Let's start with the basics. Our solar system has one sun, 8 planets, a collection of moons, and countless smaller objects like asteroids and comets, all bound by the sun's gravity, all looping around it in paths that repeat over and over. Every once in a while, though, something shows up that doesn't belong here at all. Something that came from outside our solar system entirely, passing through our neighborhood once before leaving forever, never to return. These rare visitors are called interstellar objects. And in all of recorded human history, we've only confirmed 3 of them. The first was spotted in 2017, small, oddly shaped, tumbling through space in a way that puzzled scientists for years. It showed almost no visible activity, no gas or dust streaming off it, which made it incredibly hard to study before it faded from view. The second arrived in 2019 and behaved much more like a familiar comet, with a visible coma and tail, giving scientists a richer data set, though it too was already departing by the time telescopes were tracking it closely. Both encounters left researchers wanting a third opportunity, a bigger, brighter, more active interstellar object with enough warning time for the world's best instruments to get a proper look. That opportunity came on July the 1st, 2025, when telescopes at a survey station in Rio Hurtado, Chile, part of the network called the Asteroid Terrestrial Impact Last Alert System, or ATLAS, built to scan the sky nightly for objects that could threaten Earth, flagged a faint, fast-moving point of light. Once astronomers checked its path, they found archived images going back to June 14, 2025, confirming it had been there before anyone noticed. Within days, they had their answer. This object was moving far too fast to be trapped by the sun's gravity. It would pass through and keep going, never to return. It became the 3rd confirmed interstellar object in recorded history and was named 3I Atlas, the 3I, marking it as the 3rd interstellar object. Atlas, honoring the survey that caught it. Its path around the sun was more extreme than either object that came before it, the sharpest, most hyperbolic trajectory ever measured for an interstellar visitor, moving at well over 200,000 kilometers per hour when discovered and accelerating further as it fell toward the sun. Based on how fast it's moving relative to the average motion of stars in this part of the galaxy, scientists estimated it had been drifting through space for somewhere between 3 billion and 11 billion years. Our own solar system is about 4.5 billion years old. That means it's entirely possible this comet is older than the sun, that it formed around a star that existed and died long before our own star ever ignited, then drifted alone through the galaxy untouched, until it happened to cross paths with us. Unlike the quiet first visitor, 3I Atlas turned out to be a genuinely active comet. As it approached the sun, frozen material on its surface began turning to gas, forming a glowing coma and a faint tail. And an active, outgassing object hands scientists its internal chemistry in a way a quiet, inert rock never could. The James Webb Space Telescope isn't built with fast-moving small solar system objects specifically in mind, and tracking 3IR Atlas pushed its systems in ways they weren't originally designed for. Even so, astronomers locked Webb onto the comet in August of 2025, capturing its first detailed spectrum. Then, after the comet swung around the sun, Webb observed it again in mid-December 2025 using its mid-infrared instrument, MIRI, capturing the most detailed chemical readout ever taken of an interstellar object. One set of observations, taken when the comet was about 205 million miles from the sun, and a second about 2 weeks later at roughly 236 million miles out. What came back surprised scientists. The comet showed an unusually high amount of carbon dioxide relative to water vapor, breaking the pattern typical of comets that formed in our own solar system. Then came a bigger discovery. Deep in the mid-infrared data, scientists identified the clear signature of methane gas streaming from the comet, the first time methane has ever been directly detected from an interstellar object. Webb also picked up water vapor and other chemical signatures. Methane is a small, fragile molecule, and scientists hadn't necessarily expected much of it to survive billions of years of exposure to cosmic radiation on an object drifting through interstellar space with nothing to shield it. The leading explanation is that Webb wasn't just reading the surface. It was reading material from deeper, unprocessed layers that had been shielded from radiation for billions of years, only now exposed as the comet's outer layers boiled away in the sun's heat. That wasn't the last surprise. The most recent findings, published in the journal Nature on June 22, 2026, come from a different Webb instrument, the Near-Infrared Spectrograph, or NIRSpec, which measured the comet's ratio of ordinary hydrogen to deuterium, sometimes called heavy hydrogen, along with its ratio of carbon-12 to the heavier carbon-13. What the team found was deuterium levels roughly 30 times higher than anything seen in solar system comets. That kind of enrichment points toward a formation environment that was very cold and very old, reinforcing the idea that 3I Atlas formed earlier in the galaxy's history and in a colder environment than anything that built our own solar system. Lead researcher Martin Cordner of NASA's Goddard Space Flight Center described the observation as a unique opportunity to study an object that likely predates the Sun and the solar system entirely. Webb wasn't the only instrument on this. NASA's Hubble Space Telescope observed 3I Atlas both shortly after discovery and again after its closest solar approach, revealing a teardrop-shaped cocoon of dust around the comet's solid nucleus and helping refine estimates of the nucleus's size, which came in larger than either of the two previous interstellar objects, part of why this comet produced such a bright, richer coma for telescopes to study. A space telescope called SPHEREx, built to survey the whole sky in infrared, took its own look in December 2025 and detected increasing activity along with dust made of tougher, heat-resistant material. Ground-based radio telescope arrays using ALMA detected additional escaping molecules, including methanol and hydrogen cyanide. NASA has noted that an unusually wide range of its missions and spacecraft, including TESS, SWIFT, the Perseverance rover, the Mars Reconnaissance Orbiter, MAVEN, Europa Clipper, Lucy, Psyche, the Parker Solar Probe, and PUNCH, all contributed observations of this one object as it passed through. Because the comet moved on such an extreme path and turned out to be unusually large and old, some corners of the internet speculated it might not be natural at all. Scientists took the question seriously rather than dismissing it, and pointed radio telescope arrays designed to search for technosignatures, meaning artificial radio signals, directly at 3I Atlas during its passage. The result was clear. No artificial signals were detected. Every instrument, from Webb's chemical fingerprint to Hubble's imaging to the radio searches, shows exactly what an ancient natural comet should look like. Its chemistry is unusual, but it fits within the range of what's expected from an icy body that formed around a different star. The truth here doesn't need embellishment. A confirmed visitor from another solar system, quite possibly older than our own sun, carrying chemistry frozen since before our sun existed, studied directly by our most advanced telescopes, is already one of the more remarkable natural discoveries of the decade. Why does this matter beyond the astronomy community? Every interstellar object gives scientists a direct sample of material formed around a star system they'll likely never see up close any other way. Instead of only theorizing from distant starlight, researchers can directly measure the raw ingredients that built planets and comets somewhere else in the galaxy entirely. We've had exactly 3 chances to do this in recorded history, and 3IR's Atlas delivered by far the richest data set of the 3, mostly thanks to its size, its activity, and the sheer amount of instrumentation trained on it compared to what existed in 2017. The fact that 3 of these objects have been confirmed within less than a decade, with detection technology still improving, suggests these wanderers may be far more common than once assumed. As more powerful sky survey telescopes come online, scientists expect the detection rate of interstellar objects to climb, meaning 3I or Atlas may turn out to be the third of many, rather than a once-in-a-generation event. As of today, July 19th, 2026, 3I Atlas is continuing its outbound journey away from the Sun, on its way back out of the solar system for good, and researchers are still working through the data Webb, Hubble, and the other instruments collected, with additional findings expected as analysis continues. Somewhere out there, more fragments of other solar systems are almost certainly drifting through our own right now, ancient, frozen, and unnoticed, waiting for the next telescope precise enough and lucky enough to catch them before they slip back into the dark.